weird because I literally just pressed the button on it.
Do it again.
That's the truth, I actually pressed the button and the lights went on. Anyway. Okay, so we have here transformation geometry. We're told in the question that we're going to do translation from P to P1. I've written that there. And then we're then going to do the activity of whatever the image looks like here. We're going to do axial symmetry from P1 to P2. So P1 will land on P2, and then every other point must follow suit. So I now can get rid of the t-square, and sliding set squares are going to be my preferred option here of technique to use. So if I get my two set squares, and I set up my set square from P to P1, all important points are going to go with that angle, distance and direction. So I'll take the eye of the chicken or bird, and it's going to go down at the same angle. The other eye of the bird is going to go down at the same angle. Okay, now how do I do the distance? What instrument do I do to measure the distance?
Your compass.
The compass, good. So I'll set my compass up from P to P1, and then all of the other points must follow suit. As I've mentioned before, another example of this is if you're all traveling in a car. We have a driver's seat, passenger seat at the front, and all the passenger seats at the back. It'd be very strange for a car to drive from one location to another and then to lose one of the passengers up somewhere out of the seat. Okay, so the driver gets there, the driver has travelled the angle, distance and direction of the car. Well, the passengers must do the exact same thing. Yes? What do you mean? Okay, so what I did was I set up one set square from P to P1. Yeah? And then what I did was, it just so happens that that angle is the exact same as the eye for me. Is that not the same for you? So let me just double check. So P1 is out 40 and down 120. Yeah? So 30, 90. So then it just lines up a straight line. Yeah? And then, so what I did was, once I had that P to P1 set up, I slide my set square. So I hold the second set square in place, I slide the first one along, and then I copy that same angle and direction. So it's all coming down this way. And then I will set up my compass to the right radius. Now, come on guys, we have too much talking going on here. Okay, so there we have translation has taken place. I have followed the angle, distance and direction of P to P1. And as long as you follow those rules, everything will follow suit. So now I have my new image at P1. I now need to create axial symmetry from P1 to P2. So what I'm going to do is, with my orange pen, just to show you this is again going to be my angle and distance. Now that includes the distance to the mirror and the reflection the far side. So on this orange line, I need to split that in half to create the mirror. So how do I do that? Who's going to tell me how I create the mirror? Hands up. Lucy? Okay, so we set our compass up to more than halfway just by using our eye. Swing an arc this side, good, and an arc this side. And then what do I do, Mark?
Yeah, bring it to the other side.
So swap the compass over to the other side of the line, keeping the measurement the same, and swinging 2 arcs. Where your arcs, Kirill and Nazar, watch up here, where your 2 arcs meet, you join them up, and that is your mirror. This is what we know as bisecting a line. What's bi is the Latin for what? 2, good. So this is our mirror. So now, I must go to the mirror at 90 degrees and the same distance the far side. Now just watch how I have these set squares set up, guys. I'm going to zoom out here for a second. Oh, I'm actually out as far as I can go. Now just look how I have these set squares set up. So firstly, I'm going to set one up to the P1 to P2. I introduce my second set square. I hold the second set square in place, and I'm going to take my 3 points, the eyeball, and I'm going to bring that perpendicular to the mirror and the same distance to far side. So this angle here must be 90 degrees, it must be perpendicular. Now, how do I do the same distance to far side, Nikita? How do I get, there's my image, there's my mirror, how do I get the distance, the reflection, the same distance to far side?
Measure?
Yes, with
Compass.
compass. So we take the distance from the mirror to the point, and then we act as our reflection on the far side. We take the distance from the mirror to the point that we need, and we reflect it on the far side. Then I will join up my circles. The circles are a radius 15. If I've done everything correctly, they should meet. And then all I have to do is draw on my tangent and my tangent, and I have my bird's head. What colour is a bird's beak? Yellow, is it? Would orange do?
We have to draw that P2 as well.
Yeah. Now, Emma, 1 second. Now, Emma, what's up? The knight's head. Just follow there. We'll draw the big rectangle first, I'd say. So you've drawn N, O, P, and M. Yeah? And then it's just a matter of splitting everything up. So it's basically a big square. So if I show you this here. So it's a big square, right? And then you split it into quadrants. So you have a quadrant here for the top corner. So the bottom bit is a quadrant as well. So whatever half of the bottom quadrant. So for example, I point. So from P to here is 1/4. Yeah? So from there to there is 1/4 of the whole thing, or halfway between here and here. So from that point then goes up to that corner point, that gives you that line. And then from here to here, do you know what I mean? That's a quarter. So this quadrant is split into quadrants as well. Is that okay? And so once you have that, then it should be easy enough. Now, back to this here. Okay, I have my bird's beak, and let's just test our theory and see have I done the axial symmetry right. Is everybody okay with the translation? Would you say that that image and that image look the exact same? Yeah, it just slid down, hasn't it? Now, to test to see if this is right, this might look a little bit funky because it's twisted a little bit or a little bit askew. So let's just check. Okay. Does that look the same? Let me just hide it a little bit. It's fairly close, isn't it?
Yeah.
Unfortunately, I can't hide. Yeah, I did that. So there's my reflection. You see that?
Yeah.
Now, I wish I could take a picture of that and then the actual real thing. Here's the real thing.
Well, it's way bigger.
Well, yeah, because see the way when I squash that image, it looks a bit squashed. I can't get the exact reflection of it.
It looks fairly the same.
Yeah. So there we go, okay? So that's that done. Reflection, and I've done it correctly. So, yeah? You've done that, you can't go wrong, it's done correctly. You've done your 2 steps, you've done translation and axial symmetry, you've done them right. And what did we do to do that? Well, we had our rules for translation, ADD. Follow the angle, distance and direction of P to P1. The same thing for our axial symmetry. We created our mirror, which is the bisection of the line, and then once we had the mirror, we brought all our important points to the mirror at 90 degrees, or perpendicular to the mirror, because if you don't go perpendicular to the mirror, can you see your reflection? Absolutely not. So we go through at 90 degrees, and then the distance, whatever it is, the point to the mirror, it must be the same distance on the far side. Are we all aware of that? Okay. So let's take that same theory and put it into play with